I'm Dana Thamer, a member of the software team in MindCloud and currently vice head of the software team. This is the organizational structure of our team, divided into 3 sub-teams: software, hardware, and mechanical. I'm here to give you a brief overview of our system prepared for the 2022 Minesweepers competition. Starting off, we look at the field as an area of 20 rows and 20 columns. The rover navigates through it column by column, starting at one corner and moving to the next column as it reaches the end of each one. The motion is detected and monitored using magnetic Hall effect sensors inside the hoverboard motors we use. These sensors return ticks as the motor moves, and these ticks are used to calculate the displacement the rover makes. To know the direction which the rover is moving, an inertial measurement unit or an IMU is used. It keeps track of the rover's orientation, and the change in angles are used to then calculate the rover's location on the field in terms of rows and columns. The rover's location is sent when needed to be marked on our map, published and subscribed through ROS nodes, and finally, displayed through our Python GUI. As for the communication setup, our solution was a wireless network. We use a wireless LAN connection between the pilots, the processing laptop, which will process the mapping data, and the rover. We also use a LAN connection on the rover using a switch between the wavelength antenna, the Jetson, and the IP camera. To detect the mines, we use a metal coil through which a current is passed and constantly measured. These readings are used to determine the results our metal detection board is going to return. The metal detection board we use returns both digital and analog readings. We adjust the threshold in case of the digital readings so that it can be used as a confirmation of whether the metal detected belongs to a surface or a buried mine. In both cases, the analog reading is taken and used for its accuracy. Next, we'll take a look at our hardware system. Our system consists of the main board, which is the power distribution board. This board distributes the suitable voltage to the loads by using converters to step down the voltage as needed. For protection, it has current sensors and fuses to protect the loads from any short circuits or overcurrents in case any were detected. It also provides a reverse polarity protection using a system of relays that connects the circuit only when the correct polarity is applied. It also keeps an indication for the battery level using a system of Zeners and LEDs. We also use microcontroller shields, which vary to suit all the different functions including the ARM, IMU, Hall effect, and metal detector. These make the connections a lot simpler and more user-friendly. Finally, there is an emergency switch which stops the rover immediately in case any critical problem was detected within the system. We wanted the design to be light, customizable, and durable, which required a lot of research. Finally, we chose to use aluminium as a fabrication material. Due to its natural characteristics, the body of the rover has a great balance of strength, density, lightweight, and durability for impact. For the customizable feature, we used the aluminium in profile shape, making it easy in customizable assembly as well as in base and motor installation.